Hey there, how's it going?
Hey there, I'm doing great. Thanks.
Can you show me caffeine molecule? Oh, that looks nice.
I'm glad you like it. Caffeine's molecular structure is pretty
Can
fast.
you show me the molecule for air?
Sure, I'd be happy to. But could you please complete your request? Just
Air molecule. Can you show me air molecule?
air isn't a single molecule, but rather a mixture of different gases.
Oh yeah, that's right. You know what? Then you sorry. Okay, show me the most basic plastic molecule. Oh, this is polyethylene. This looks like a little
A-
caterpillar.
That's a fun way to put it. Polyethylene does resemble a caterpillar with its long
Can
chain.
you show me the next one?
Could you clarify?
Like the second interesting plastic molecule.
Let's explore another interesting plastic molecule, polyvinyl chloride, or PVC. It's widely used in construction for pipes,
Oh,
cables.
this definitely looks like a caterpillar.
It does, doesn't it? Those repeating units give it that caterpillar like appearance.
Sweet,
Polyvinyl.
thank you very much. You're very helpful. Appreciate it.
You're very welcome. I'm glad I could help. If you have any more questions or just want to chat,
Okay, so this is a Molecule Explorer app that I built with OpenAI real-time voice and client-side function calling. You can actually try it out with your own API key at molecules.app.railway.app. The link to the app will be below. And you can also download the app code by becoming a patron. When you become a patron, you get access to 400 plus fascinating projects like this and future updates. So this is possible because this Fast API app that we are using actually is only used to get an ephemeral API key from OpenAI using our own API key. Ephemeral API keys are provided on the go and expire each minute, I believe. I'm not 100% sure, but I think they are generated each minute. And we send this to the front end, and the JavaScript actually takes care of all of it. And the key parts here are actually the functions. Here we have some functions defined. For example, here the display molecule info with its 3D structure, which returns the name of the molecule and array of chemical elements. Now, we are actually using this not to retrieve the exact molecule structure, but allowing model to return it like a structured output. And we do run a function to display this on the screen using Three.js and some cool libraries. But essentially, the molecule structure may be inaccurate. It is at the end of the day using the real time GPT model, voice model. So just keep that in mind. The JavaScript is quite long and does most of the heavy lifting. And index.html is quite long too, which just kind of puts everything into its place. But I guess the interesting thing here is the libraries that are being used. Like we are using anime.js, Three.js, orbitcontrols.js, and chart.js to actually display the statistics about the molecules, such as the molecular weight, bond count, atom count, and things like that. So this is an interesting project. You can download it as a patron if you choose to become one. I have two versions available, one that can be deployed, which uses users API key, and another one that you can just run locally. We are currently looking at the one that actually uses users API key. So as you can see, we are using GPT-4o real-time preview, which was just released yesterday as of the release of this video. Slash route just delivers the index.html session, creates the ephemeral token, delivers it to the front end. We do make our connection in the front end to the API, actually. Right here, initializing WebRTC connection. So this probably isn't really ideal for production. I'm not sure what is the ideal. This is pretty new for me, but this works. So the connection, since the connection is made in the front end, we can actually define our functions and function definitions in the front end, which allows for really interesting use cases such as this. So you can try it up at molecules.up.railway.app, see what you think. Make sure to keep in mind the costs associated with it. And I'm now going to let my AI code explainer explain the code because this is quite long and I actually don't understand parts of it because I use Cursor to build it. And both this app plus the AI code explainer is available at my Patreon. Thank you for watching. So let's get to the code review.
This section of the code sets up the core structure for the Molecular Voice Explorer using FastAPI. FastAPI is a modern web framework for building APIs with Python 3.6 plus types, perfect for quick iterations and quick deployments. What this does: 1. Imports key libraries that facilitate the web application, manage HTTP requests, handle responses, and add color to terminal outputs. Always nice to have the terminal say hi in colors. 2. Sets a constant model referencing a specific OpenAI model, in this case, detailed as a future model version, suggesting a forward-thinking approach over Achiever Alert. 3. Initializes a FastAPI application named Molecular Voice Explorer. 4. Mounts static files for serving additional resources through a static directory, which might include style sheets, scripts, and the essential Jinja 2 templates for rendering HTML. 5. Defines an endpoint to serve the main HTML page, index.html, using Jinja 2 templating, providing a friendly web interface for users. These actions create the bake skeleton on which the application runs, providing files and basic interfaces, and logging in the terminal with colorful insights. This code snippet deals with creating a session using the OpenAI API, which is crucial for enabling the molecular exploration via voice commands. What this does: 1. Defines an API endpoint/session that attempts to establish a session with OpenAI using the specified model and voice settings. 2. Checks for the presence of an authorization token in the request headers. If absent, it raises a value error indicating that the user needs to supply an API key. No key, no playtime. 3. Utilizes HTTPX, an asynchronous HTTP client, to handle the external API request to OpenAI. This is where the molecular magic potentially sparks into action. 4. Deals with responses. Successfully created sessions are responded with JSON data. Errors like API key issues or other hiccups are greeted with a polite error message for the client to digest. The intent here is to safely and effectively connect to OpenAI's real-time voice API, enabling molecular exploration features through voice commands. This step secures the connection, ensuring the application only proceeds if configured correctly with an operational API key. This snippet handles the main entry point for running the FastAPI application. What this does: 1. Checks if the script is being run directly, as opposed to being imported as a module, which triggers the server startup. 2. Uses Uvicorn, a lightning-fast ASGI server, to run the application on localhost port 8000. It's like calling in the bouncers to keep things running smoothly in the FastAPI club. 3. Utilizes the Reload It's True option to automatically restart the server upon changes in the code, promoting a flexible development environment that likes to live on the edge. Starting the server is crucial, as it opens up the gateway for the application, ensuring users can make API requests and view interfaces via browsers. Welcome to the front-end face of Molecular Voice Explorer. This section initiates the HTML file, setting up the skeleton for a dynamic, visually appealing, and highly interactive user interface. What this does: 1. Outlines a typical HTML document structure with essential meta information, such as character set, viewport settings, and a cheeky title hinting at the magic here: exploring molecules through voice. There are 2. Links to various external CSS and JS libraries, such as Tailwind, Daisy UI, Anime.js, and 3, which bring in stylish design elements, snazzy animations, and powerful 3D visualization capabilities, the Avengers of the web development world. Number 3. Begins rendering the core body of the HTML, setting up the canvas on which components will dance, dazzle, and deliver the Explorer's features to the users. With this part of the code, we're building the foundation for a responsive, user-friendly interface that can render molecular structures and respond to user interactions. This HTML snippet is all about the header section, setting the tone for the Molecular Voice Explorer. What this does: 1. Introduces a flexible header that changes its layout responsively depending on the screen size, Flex Magic at its best, featuring the echohive.live link indicating the creator or hosting space, hence marking the beginning of its interactive nature with a gradient text shine. 2. There's a button to set API key, prompting users to open a modal to configure their personal OpenAI key, a key step to accessing the juicy Explore molecule using voice commands. Imagine locking the treasure chest but keeping the key real easy to find. Bubber 3. A call to action button with a catchy pulsing animation, encouraging users to download the app code, possibly directing them to a fundraising hub, Patreon, for maintaining and expanding this exciting project. It's the digital way of passing the hat for contributions. The header provides users with essential interaction points right off the bat, making sure they know how to set up their API key, learn more about the app's code, or explore related projects. This part introduces a user-friendly how-to-use guide, essential for navigating the realm of molecular voice exploration in style. What this does: 1. Introduces a button that toggles an instructional section, giving newbies, or pros needing a refresher, an easily collapsible guide to use the application. Who needs cryptic runes when you have a scripting guru? 2. Lays out step-by-step instructions to set up, enter an API key, start voice navigation, and delight in molecular tour commands like show me the structure of water. 3. Encourages interaction through voice commands, thus transforming users into molecular explorers, pushing them to utter the right magical phrases for results. 4. Presents options to manipulate the view style of molecular models using the visualization controls provided, turning an educational experience into an engaging 3D puzzle. The guide plays a pivotal role, providing users with operating instructions and encouraging the proper setup for an optimal exploratory experience. This extensive section forms the heart of the Molecular Voice Explorer's HTML design, housing the interactive molecule display and controls. What this does: 1. Contains the main interface for viewing and exploring molecules, fitting into a neat visual card format. It's the heart and the engine room of this noble expedition where molecules are ready to be discovered. 2. The molecule container acts as the stage for 3D molecular visuals, with status indicators softly whispering, "Connections lost," or "It's loading," like gentle reminders. 3. Visual customization is prioritized, allowing users to toggle views, ball and stick, or wireframe anyone. This enables a personalized exploration suiting the user's whim. 4. Voice controls spring into life with start-stop navigation buttons, giving users that powerful feeling of talking to their computers without feeling too futuristic. 5. The molecule stats section showcases live stats like bond count or molecular weight once a molecular masterpiece is selected. It's like a science fair on steroids, but safely controlled via APIs. Overall, this code snippet crafts an immersive presentation facilitating molecular exploration through a clear, engaging interface, brewing excitement for scientific adventures. Closing up the HTML file with this snippet, which adds the finishing touches for interaction via a modal. What this does: 1. Introduces a modern modal dialog dedicated to acquiring and securely entering an OpenAI API key. The dialog keeps the user focused, and input is temporarily stored, promoting seamless access to OpenAI services. Facilitates the save functionality within the modal, ensuring users' API keys are securely entered. It's like putting the key to unlock molecular wonders safely away, but still easy for you, and only you, to find. 3. The link to JavaScript at the end embeds dynamic behaviors tied to /static/app.js, fueling the interactive components scattered along the page, a vital cog in the app's powerhouse. The modal function and associated scripts ensure users are well prepared with the necessary authorizations, providing the final nudge toward exploring molecules with voice in an intuitive, controlled manner. This code segment handles API key management for the Molecular Voice Explorer application. It comprises 3 functions. 1. Open API key modal. This function displays a modal dialog where users can input their OpenAI API key. If a key is already stored in local storage, it populates the input field. 2. Save API key. It saves the entered API key along with its expiry time in local storage. The expiry is set for 48 hours to ensure periodic refresh for security and session management. 3. Get stored API key. Retrieves the stored API key, checking its validity and expiry. If expired or non-existent, it removes the stored key. This section is vital as the application relies on authenticating API requests to OpenAI's services, ensuring secure and efficient access. This segment manages UI interactions, particularly expanding and collapsing sections on the web page. Toggle How to Use toggles the How to Use content section, changing the arrow's direction for visual feedback, indicating expansion. Toggle Controls similarly toggles the visualization style controls. DOM
We
content
set out
loaded
to answer
listener
the question.
checks for a stored API key when the page loads, prompting users to set their API key if not already set. This segment contributes user-friendly navigation and reminders throughout the app, enhancing overall usability. In this segment, we declare and initialize DOM elements and global variables that are crucial for user interaction and WebRTC operations. The DOM elements, start button, stop button, etc., are hooked up to corresponding elements on the page to facilitate interaction control, like starting, stopping actions, and displaying messages. Global variables are set up to manage WebRTC connections, media streams, 3D rendering components, and UI states. This setup is essential for connecting the physical user interface to the underlying logic, ensuring that any change in the UI is reflected in the internal state of the application. Here, we define two objects, atom colors and atomic radii, which provide color codes and atomic radii for various elements. Atom colors maps each known element to a color in hexadecimal for use in 3D visualization, enhancing the visual differentiation between atom types in the rendered molecular models. Atomic radii offers default radii for atoms, crucial for accurate scaling in molecular renderings. These configurations support the 3D visualization component of the application, ensuring visual clarity and scientific accuracy in molecular representations. This segment initializes a 3D viewer using 3.js, setting up the scene with necessary elements. Scene in Camera creates a 3D scene with fog effects for depth perception and sets up a perspective camera. Renderer prepares the WebGL renderer with optimized settings and appends it to the DOM. Lighting adds ambient and point lights to illuminate the scene realistically, alongside hemisphere lighting for subtle highlights. Controls initializes orbit controls for interactive scene exploration, with smooth damping and auto-rotation. Resize handling ensures that the scene scales dynamically when the window size changes. Demo molecule, water. A predefined water molecule is loaded to provide users with immediate visual feedback. By establishing the 3D visualization framework, this code segment is foundational for the molecular rendering component of the app, enabling users to interact and visualize molecules vividly. The createAtom function is responsible for generating the visual representation of atoms in the 3D space using the 3JS library. Customization by style. Depending on the user-selected style, space filling, wireframe, cartoon, ball and stick, the function adjusts the geometry and material attributes for each atom. This flexibility allows users to view the molecular structure from different perspectives and detail levels. Material properties. Attributes like metalness, roughness, and reflectivity are tailored to give each atom a realistic or stylized appearance as per the selected rendering style. Glow and labels. If enabled, the glow effect is added for enhanced visuals unless in wireframe, and element labels are appended for clarity. The function integrates atom visualization seamlessly into the molecular viewer, aiding users in identifying and analyzing the molecular structure interactively. The createBond function constructs the bonds between atoms using 3JS, complementing the molecular visualization. Directional setup. Bonds are created between atoms by determining the vector direction and length between 2 points, ensuring precision in molecular structures. Style switching. Similar to atoms, bonds adapt their geometry and material based on user-chosen visualization styles. This includes physical, tune, and wireframe styles, each influencing the bond's appearance. Positioning and orientation. Each bond is positioned midway between connected atoms and oriented correctly using lookat, maintaining structural integrity visually. This function is pivotal in forming the network of connections within the molecular visualization, enhancing the 3D structural analysis of molecules. The createGlow effect function adds a glowing aura around atoms in the 3D scene, enhancing visual appeal and depth perception. Shader material utilizes a custom shader material with vertex and fragment shaders to simulate a glow effect based on the viewing angle and distance. Configuration. The effect is configured by altering uniforms like glow intensity and color, which are blended additively for a bright aura. A slightly larger sphere encases the atom, applying the glow shader to create a luminous border around it. This effect is particularly useful for highlighting significant atom segments in a molecule, contributing to the visual differentiation and aesthetic richness of the molecular mode. The Create Atom Label function generates labels for atoms, enhancing their identification within the 3D molecular viewer. Canvas setup. A small canvas is prepared to render text using canvas.getContext2D, offering a flexible medium for drawing labels. Text configuration. The element's symbol is inscribed in a bold central format, maintaining readability and distinctiveness. 3.js integration. The canvas is converted to a texture used in a 3-dot sprite material, which attaches it to a sprite positioned above the atom, ensuring it's consistently visible. Labeling atoms facilitates easier recognition and interaction, aiding users in understanding molecular formations by directly linking visual content with chemical data. This function, createToonGradient, sets up a simplistic gradient texture to be used in the cartoon rendering style. Gradient configuration. The data texture holds a bright, segmented gradient spanning from low to high luminance. Purpose. Used within toon shading to provide distinct, banded lighting effects, adding an exaggerated, stylized look. It adds a playful touch to molecular visualizations, perfect for educational or illustrative purposes. This snippet handles the dynamic updating of molecule visualization styles in response to user interactions. Style update. The update visualization function redraws the current molecule using the latest visualization settings. When styles or effects like labels and glow change, this function ensures the rendering remains accurate. Interactivity. Event listeners on style control buttons and checkboxes allow users to toggle between different visualization modes, e.g., ball and stick, space filling, or effects, labels, glow, providing an interactive visual experience. This adaptability allows users to tailor the molecular display to their specific needs, whether for detailed inspection or general understanding. In this segment, the display molecule function exhibits a molecule within the 3D environment, syncing animations and visual updates for an engaging user experience. Preparation. Prior labels and scene elements are cleared and scene lighting is reinitialized. Animation and grouping. Atoms and bonds are added to a 3-dot group with anime.js for smooth positioning animation, portraying molecule formation dynamically. UI updates. Updates molecular metadata on the UI, offering comprehensive insights like molecular weight, bond count, etc. Camera framing. Adjusts the camera's view to focus on the newly displayed molecule structure, centralizing it perfectly. By managing to dynamically visualize the molecules with animations, this segment significantly enhances the molecular analysis experience through engaging visual representation. The Update Electron Chart function crafts a detailed electron configuration chart using the chart.js library. Recreation and configuration. Destroys any pre-existing chart to maintain freshness, then leverages a context from the canvas, setting up a bar chart representing electron distributions. Data visualization. With labels and color coding, the chart provides a succinct visual overview of electron configurations. By visualizing electron arrangements, users gain a deeper understanding of molecular structures, making it an informative tool in the molecular analytics arsenal. The Initialize WebRTC function sets up a WebRTC connection, crucial for real-time communication in the application. API key verification. Starts by verifying the stored API key to ensure there's valid authorization for communication with the OpenAI API. Remote token gathering. Retrieves a temporary session token, which facilitates secure and temporary communication. Audio and connection setup. Establishes WebRTC RTC peer connection for real-time audio data transmission, creating an audio stream and a data channel to handle commands and feedback. Offer answer mechanism. Utilizes SDP, Session Description Protocol, to negotiate streaming parameters with the OpenAI servers. This setup enables seamless voice command functionalities, a core feature for the interactive molecular exploration experience. The Configure Tools function is responsible for defining and sending a configuration to OpenAI's API via the data channel. Session configuration prepares a session update object with modalities for text and audio detailing the functionalities supported. Here, it defines a display molecule info tool. Tool specification describes the function parameters needed to render a molecule in 3D, covering details like atoms, bonds, and properties essential for understanding molecules. This step ensures that the WebRTC connection has a clear understanding of the tools and actions that the user can invoke during their session, thus laying the foundation for responsive, voice command-driven molecular interaction. The Handle Data Channel message function listens for messages on the data channel, especially those initiating function calls. Message parsing processes incoming messages, checking for response.function_call_arguments.done, which indicates completion of an asynchronous function call command. Function handling. Upon receiving commands like display molecule info, the function parses the arguments and calls the appropriate method to update the molecular display. Acknowledgement sends a confirmation back to the API, signaling successful execution of the function. This logic ensures effective communication and execution of voice commands, cementing the real-time interaction feature. The cleanup function is crucial for gracefully terminating a WebRTC session, releasing system resources, and resetting UI states. Media tracks and audio cleanup stops all active media tracks and removes any audio elements, ensuring system resources like the microphone are freed. Scene and connection closure clears the 3D scene of any children to avoid memory leaks and closes the data channel and peer connection. UI status update updates the connection status on the UI to reflect disconnection, making it user-friendly as it guides users on interaction availability. Such robust cleanup practices are essential for maintaining performance and ensuring a snappy application experience upon repeated use. This userful snippet contains utility functions that provide user interface updates and feedback. Update status adjusts the on-screen status text and color indicator based on connection state to inform users about the current operational status. Add message appends informational or error messages to the UI, helping keep users informed about application events or issues. Show loading manages the visibility state of a loading animation to visually communicate ongoing processes, enhancing user experience by not leaving them guessing about app states. Together, these utilities promote a smooth and interactive user interface, making the application more engaging and responsive.
Now, listen to me. I've been trying to code, and I like coding. The fact that I can code and make things happen, but how do I do it? I mean, fast with AI. I'd heard about it. It's easy. So I came across 1000x cursor course. And that's great, it just made everything super silky smooth. It just worked. I'm telling you.
1000x your coding.
I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.